In this video, we're going to be looking at systems of linear inequalities. So instead of having the equation of a line where you have the equal sign here, we're not going to have the equal sign. We're going to have one of these inequalities. So instead of equals, we might have strictly less than or equal to, greater than, or greater than or equal to. Now, when you have an equal sign, you get a line. When you have an inequality, you get a region. And to determine the region, you have to make sure your inequality is written with y by itself on the left-hand side. So if we have y by itself in the left-hand side, and then a strictly less than symbol, we're going to want the region below the line that you get if you were to replace that with an equal sign. For the less than or equal symbol, you want the region on and below. For the strictly greater than symbol, you want the region above the line. And for that symbol, you want on and above the line. So let's see what we mean. Let's see if we can find the solution region for this. Okay. Well, the first thing you're going to have to do is you're going to have to rewrite that to where both those inequalities to where y is by itself on the left-hand side. And when you have an inequality, sometimes the arrow will flip. Your arrow will flip if you multiply or divide both sides by a negative. So I think we can all see that that is true. Well, if I multiply both sides by -1, that arrow is going to flip, because on the number line, -2 is to the left of -1, so -2 is certainly less than -1. Or -1 is to the right of -2, so -1 is larger, greater than -2. What else will make an arrow flip? If you swap sides. So again, we can all see that 2 is less than 3. If I swap the sides, the arrow flips. All right, so if I want to see these in my graph, my graphing calculator, I have to rewrite them with y by itself. So for the first one, I'm going to subtract x from both sides. Subtracting does not change the direction of the arrow. For this one, I'm going to subtract 2x from both sides. Does not change the direction of the arrow. But I need y by itself, and this is -y. So I'm going to multiply every term by -1, and when I do that, it will change, it will flip the arrow. So now I have my system. Okay. Now, what regions am I going to get? Well, let's look at this region. So if I look at that one first, we want the region strictly above, because it's the greater than symbol and equality is not included. We want the region strictly above the line y equals -x. So clear that. Oh, clear that one too. So for the first one, for y strictly greater than negative x, we just want the region above, and we would draw that line dashed because it's not included, because equality is not part of the symbol. So I'd get the blue region. Now for the second one, we want, because of this symbol, we want the region on and below the line. So for that one, if I get that, so I'm going to put this one to sleep. And I'm going to look at the line 2x minus 3. So, whoops, let me get that back. So what I want for that, let's try this one more time. Okay, so for that region, I want on the line and underneath. And so I include the line and I want everything underneath. So what I've drawn there. Now for the system, you want to see where is the overlap. So you're going to put them in the same graph. I'm going to come here and I'm going to wake this one back up. All right, so for this one, we simply wanted the region above the graph, above the line, sorry. And then for this one here, we wanted on and below. On and below. And so now, when they're on the same graph, you need to see where the overlap region is. And the overlap region is in here. Now, your final answer will only contain the overlap region. So we included this line. This line was not included, so we had to draw it dashed. But the only thing you want at the end is what I am drawing in the black. And so your final region is this. Now, what if you were asked to find that intersection point? Well, if it's easy enough to identify, you can look at it on the graph and see what it is. But if not, you can always ask your graphing calculator to do that for you. So I'm going to show you how to do that. Press second key and the trace key and come down here to intersect, then press enter. And you see this flashing ball. Now you can only use left or right cursor. So I'm going to move this flashing ball to where the intersection is. And that's good. So it's on the first line. So I'm going to press enter. Now on the second line, I like it where it is, so I'm going to press enter again. Then it says, do you want me to guess what the intersection point is? Yes, I do. Press enter again. And it's told me that the intersection point is the point 1, negative 1. Okay, so that's a nice way to get it to do it for you. Okay. All right. Now, as we know from Math 100, vertical lines have the equation x equals a number. So that's a vertical line. So with vertical lines, it doesn't make sense to be above or below. So in the case of vertical lines, the symbols will be interpreted as right or left instead of up or down. So let's sketch this region. Okay. All right, so We know what the line x equals -2 looks like. All right, so that's going to be done over here, but I'll do it out here. So I have the line x equals -2. You can see from the symbol the line is not included, so I'm going to draw it dashed. And then the arrow is pointing to the right. So in the case of a vertical line, it will be to the right or left, because up and down doesn't, above or below doesn't make any sense for a vertical line. Then in the case of this, x is less than or equal to 6, well, if that's where 6 is, then we include the line, and the arrow is pointing to the left, so we include the line and everything to the left. Now the answer is going to be, when they're on the same graph, what is the overlap? And we should be able to see that the overlap is going to be, I include this line, I do not include that line there, and I have everything in between, because that's where the overlap is. So my final answer is going to look like that, okay, which we have here. So the final answer should only show the overlap region. And notice here this line is contained and that line is dashed. And so we have our final answer there. Okay, that's what your final answer should look like. All right, now what if you want to sketch this region? The very first thing you need to know is when you have those two together, that is restricting you to the first quadrant, which is here in purple. And so before it just shows you how you get there. X greater than or equal to 0. Well, x equals 0 is the y-axis, so it's included in everything to the right, so that's in red. Y greater than or equal to 0. Well, y equals 0 is the x-axis, and everything above, which is shown there in blue. Put them in the same graph. Where's the overlap? The first quadrant. Now we're going to use that at the very end. Okay? We will come back to that at the end. So now let's concentrate on these other two. Okay, so let's look at the x plus 3y is less than or equal to 6. We want to see that in a graph. So we need to write that just with y by itself on the other side, on the left-hand side. So subtract x from both sides. That does not change the arrow. And then divide both sides by 3. Dividing by a positive does not change the arrow. And 6 divided by 3 is 2. So I'm going to want, the region I want here is everything on that line and below. And so this is the line, y equals minus x over 3 plus 2. That's the line, so we want the line and everything below. So that's shown in red. Next, we want to look at that, but you want y by itself. So subtract x from both sides. Subtracting does not change the direction of the arrow. And now to get y by itself, multiply everything by -1. Multiplying by a negative flips the arrow. So if I multiply this by -1, I get y. The arrow is flipped. If I multiply that by -1, I get x. If I multiply that by -1, I get that. So now I want the line y equals x minus 2, which is this. And I want everything above, which is in blue. Okay. What I'm going to do next is I put both of those in the same graph. Okay, so let me get the formulas for the same graph. Come Come down here, and let me come here, go there, and I'm going to get rid of that. So this first one was y equals negative x over 3 plus 2. And the second one was y is equal to x minus 2. Okay. Now in the standard window you can see, well, maybe not, but for this one here, we wanted the line and below. So I'm going to put them in the same graph. So we wanted the line and below. And then for this one here, we wanted the line and above. And then where is the overlap? Well, I think we can all agree the overlap is here. And so our final answer is going to be just the overlap. Okay, so let's see what we did on the next page. Okay, so looking at the red and the blue overlap gives that. And then I've enlarged it there. So I put the window, instead of being a standard from negative 10 to positive 10, I've, let's see, I think I took this to go from negative 2 up to 4. And the same with the y. Looks like maybe negative 3. And then press graph. Okay. All right, so our overlap area is what we have here. So we took this region here and we saw where the overlap was, which was in here. And our final answer for these two should just be the overlap. Okay, so this is what we have for that. So your last step is going to be to incorporate that into it. And at the beginning we saw that that was the restriction to the first quadrant. So if I'm going to get all of this now, I need to take this purple and restrict it to the first quadrant. So I'm going to get this region here. And that's going to be my final answer. Let me... Okay. And I'll do that on the graph. Yeah. Now, when you have an enclosed region like this, you're going to need to know the vertices, corner points. Now, it's easy to see. This corner point is the origin. It's also easy to see that this point here is 2, 0, and this point here is 0, 2. So when they're on the axes, they're pretty easy to tell. But what about that one? Well, it's actually 3, 1, which you can kind of see from the graph, but again, you can ask it to calculate the intersection point for you. Okay, so I'm going to do second and trace, and I'm going to come down here to intersect. And for the first curve, which is the first line, you can only use left or right. So I'm going to move this flashing ball to where I think the intersection point is. And I'm going to press enter. Then on the second curve, that's pretty good on the second line, so I'm not going to change that. I'm going to press enter. Then it says, do you want me to guess? The graphing calculator is asking you, do you want me to guess at what I think the intersection point is? Yes. So press enter again. And it's telling me that the intersection point is the point with x coordinate 3 and y coordinate 1. That's what it's telling me. Okay. So that's how I get the region and the vertices, the corner points. And we will need that, as you're going to see in a bit. Okay, but we do another one. Okay, let's sketch this region. Okay, some of these you can do straight away. First of all, if it's y equals a number from Math 100, that's a horizontal line. And we can actually do these in the same graph. Okay, because y equals -3. So y greater than or equal to -3. I want the line y equals -3 and everything above it. Okay, so this strip will go on forever. Okay, and now y less than or equal to 5. Well, the line y equals 5, I want it, and everything below. Okay, now where is the overlap? Well, I think we can see that I'm going to get the lines and everything between them. So just in black is my overlap. That's going to be my overlap, and that's what I've done over here. All right. So that eliminates those. And now I'm going to take this graph and I'm going to incorporate that region. So if I do that, I'm going to incorporate, so so right now I've got this region. It goes on forever. But now I'm going to incorporate this part in. So x equals 6 is a vertical line that goes through 6. And I want everything on the line and to the left. So when I overlap the black and the red region, I'm going to get this. So now what you see there is those three incorporated. And now the only thing I have to do is to incorporate this line into it. So what is this line? Well, if I subtract 2x from both sides, that does not change the arrow. So I'm going to have that line. I want everything on that line, which was something that looked like that, and above. So you can see that the black and the blue overlap there. And so this is where I get this figure here. So after I incorporate all of that, this is my bounded figure. Now, some of these will be easy to identify, the corner points. This is the line y equals 5. That's the line y equals 5. So with these points, their y coordinates are 5. This line here is y equals -3, and so the y coordinate of that point is -3. But this vertical line is the line x equals 6, so the x coordinates equal 6. Okay. And that one there has y coordinate -3 because it's on that horizontal line. You just have to get the x coordinate of that. And again, you can get it on your graphing calculator. So this one, that should be a -2x. Okay. So I subtract 2x from both sides. Okay. So let's get the graphing calculator back there. And come here and clear it all. And if I want to get these points here, let's get y equals 5, y equals -3, and then y equals -2x minus 1. And let's do a zoom 6. Okay. Now I have the x equals 6 is going to be about here. And so I already know those points as we did before. 6, 5, and 6, -3. But now I want to find those. So if I'm going to find those, I need to just have 2 lines on the board. So, sorry, let's put -3 to sleep. So if I just want to see where that intersection point is, I do second trace. And we want intersection point. And I'm going to move my cursor to where the intersection point is and go enter. On the second curve, yes, enter again. You want me to guess? Yes, guess. And it's telling me that intersection is -3, 5. Now, if I want to get this intersection, I need to put this line to sleep and turn that line, wake that line back up. So I'm going to put this over here and press enter. That puts it to sleep. And then I'm going to highlight that one and it wakes it up. If they're highlighted, they're going to appear. Now I want that intersection point there. Those are the only 2 lines I have showing. So second trace, down to intersect, and move the cursor to the right. Yep, enter. Second curve, enter again. And you want me to guess? Yes, I do. And it's telling me 1, -3. And so now if I go back and turn all the lines on, (1, -3). And so I have all my corner points of the region. Now in the notes here, I found the corner points without using a calculator by substituting in. So either way you want to do it. Okay, now an objective function is a function written with two variables, x and y. So a and b are just numbers. And so it's written as z, that's our function, equals, it's a function of x and y. And it's part of an optimization strategy that finds a minimum and maximum value. So for the one that we just did, find the minimum and maximum values for this objective function. For the one that we just did, so here's our region. And what you're going to do is you're going to start with the corner points, and you're going to plug the corner points into your x and y values for your objective function. So let's start with the vertex 1, -3. Well, your x value is 1 and your y value is -3. So for this objective function, z is going to be equal to 7 times your x value minus 4 times your y value. So that's a y there. And that's going to give me 7 plus 12, which is 19. Okay, so that's what we have there. And if I go clockwise, my next vertex is -3, 5. And so now my objective function becomes 7 times my x value minus 4 times my y value, which is going to be -21 minus 20, which is going to be -41. And now moving on to the next vertex, which is 6, 5. Then my objective function is going to become 7 times the x value minus 4 times the y value. So it's going to give me 42 minus 20, which is going to be 22. Okay, and finally, my last vertex, my objective function becomes 7 times the x value minus 4 times the y value, which is going to be 42 plus 12, which is going to be 54. Now, if you're asked for minimum and maximum, we can see that we have a maximum of 54, and it's found at the vertex 6, -3. And we can see what our minimum value is. Minimum value is -41, and it's found at the vertex -3, 5. And so let's do one more. Let's have the same objective function and find the minimum and maximum values for it. Okay, so this was the one that we did where we got these corner points. So it's bounded, so it's closed in. We don't have an open end going off forever. So again, I'm going to start at 0, 0. So my objective function is going to be 7 times 0 minus 4 times 0, which is 0. And my next one is going to be that. So my objective function is going to be 7 times 0 minus 4 times 2. So that's going to give me -8. My next vertex is this one. So my objective function is going to be 7 times 3 minus 4 times 1, which is going to be 21 minus 4, which is going to be 17. And then lastly, for the vertex 2, 0, my objective function is going to be 7 times 2 minus 4 times 0, which is going to be 14. Now, out of all of those, my maximum value is going to be 17, and it's found at the vertex 3, 1. And the minimum value is -8, and it's found at the vertex 0, 2. Okay, so that's going to be the last of this video, and so you should be able to have a go at your web work problem.